This is 7.1, part 2. Now we're going to get into an application problem. Let's pretend we have some bacteria that we're watching. And we're given that we have 55 bacteria in our Peachtree dish. We want it to double every hour. And our first question is, how much bacteria will be in our dish after 3 hours? So let's just kind of do this the long way, where we have our initial time equaling 0, and the amount of bacteria, the population, is 55. Then, if it were to double after 1 hour, how much will be in our dish? So we just multiply that by 2, or 55 plus 55 is 110 bacteria. Now let's go into 2 hours have now gone by. What will we have? We're going to double it again. So what will happen to 110? We will double that number, and we get 220. And then we have 3 hours. The population, 220 times 2 is 440 bacteria. That is our answer. What I'm going to do on the next part is actually to show you how to do the same problem, but with the formula in the purple. So the doubling represents your increasing the population over time. So it's a growth rate. And our growth rate, we are doubling the number. So our growth rate is 2. And this is our initial population. That's our A. And then this is going to be our B in this formula right here. Then the X is our time. How long will we watch this population for? Well, it's going to be 5 hours. So let's go ahead and substitute into this purple formula. So Y is our ending amount of our population of our bacteria. Our initial A was 55 bacteria. Our growth rate multiplier, we're doubling it, so it's times 2. Raised to how long we're doing this for is 5 hours. Now think back to when we were evaluating our expressions. You do the exponent first. So 2 to the 5th power is the same thing as 2 times 2 times 2 times 2 times 2. Well, or plug it into your calculator. 2 to the 5th is 32. Now multiply that by 55, and the bacteria that you'll have is 1,760 bacteria after 5 hours. You could also use the formula up here. Instead of continuing doubling it, let's check it. The initial 55, the multiplier, and how much time has gone by? 3 hours. So 2 times 2 times 2, or 2 to the 3rd, is 8. And then 55 times 8 is 440. It checks off. Same answer that we got over here, doing it the longer way. Next example. The population of Cottage Grove is roughly 34,000 people and is increasing at a rate of about 2% per year, so we're growing. Find the population in 1 year of that growth rate, and then in 7 years. So what we have to first find out is, what is the growth rate multiplier? Before we can answer substituting in the formula. So we are increasing at 2%. So if it's a growth rate, we add 1 plus, remember 2%? Well, we can't do 2% with our calculators, we have to change it to a decimal. So we move it 2 places to the left. So we get 1.02. And this is our growth rate multiplier. It's our B in our formula. And then this is our initial population. That is the A in the formula. Now we can answer the first question. How many people will be living in Cottage Grove after 1 year? This is the X of our equation. So let's go ahead and substitute in the three pieces. Y is the end amount. A is your initial amount of 34,000 people. Our growth rate multiplier is 1.02, and the time is 1 year. Now we go ahead and 1.02 raised to the 1 is still just 1.02. And now we multiply 1.02 times 34,000. And the amount of people living in Cottage Grove after 1 year at 2% increase is 34,680 people. We can do the same thing again now for 7 years. So we have that initial 34,000 people, our growth rate multiplier of 1.02, but now we're raising it to the 7th. So put in 1.02, raise to the 7th, and then go back and multiply it by 34,000. With your calculator, you should be able to get 39,055 people. I think we're going to skip this one. It's very similar to the one that we just did with people. This is money, and we're increasing at 3%. We want to find out how much money we'll have after 4 years. The assignment for 7.1 is on page 493, 1 through 11.